sometimes I do overlap with the information, but sometimes I don't. So I'm probably going to overlap a little bit today because it's reinforcing the slope. And it's all about the slope. When you get into Calc 2, it's all about the slope. So, all right. So let's start with 3.2, number 37/12. 3.2, 37/12. And here is the question. I'm just going to ignore the directions because I'm going to show you how I want you to do things for my test. Okay? So f of x is equal to square root of 3x plus 4, and x is equal to 4. I don't know why they just can't do that, but they try to confuse you no matter what. So there is the question. Now, the first thing I want you to do on my test, the first thing I want you to be able to do is give me a point. How can you give me a point? X comma y. So plug that in. Yep, plug that in. 4 times 3 is 12. The square root of 16 is 4. And you're going to need that later. So that's the first thing I tell students to do. And we already went over this before 3.1. 3.1 confused a lot of people because that's what it does. When you put the difference quotient right beside the instantaneous velocity, it's instant confusion. That's why I try to keep it separate. All right, the second thing. So number 1, get you a point. Number 2, we're going to plug it in the difference quotient. So I want everybody to plug this in the difference quotient. So I'm going to write a big set of, let me get my green and my orange out. And I'm going to write big set of parentheses plus 4 minus in red my orange f of x 3x plus 4 all over h. And what are we going to plug in? X plus h. Now, I'm going to get the red marker out. We've got radicals. What have I told you about radicals? When you see radicals with the difference quotient, when you see radicals with the difference quotient, that means you're going to have to use the what? The conjugate. Okay, so go ahead and write that down because you're going to have to eliminate the radicals in the numerator. So whenever you see a radical problem like this and it says differentiate and you don't know how to do the chain rule, this is the only way to do it. So now we're going to have the square root of 3x plus 3h plus 4 minus the square root of 3x plus 4 all over h. Okay, now what is the conjugate of the green radical minus the orange radical? What's the conjugate? The green radical
plus the orange radical.
Thank you. So I'm going to take my handy dandy. What color have we not used? Let's go with this. I done used up my fluorescent blue. I got to get a new fluorescent blue. Let's use silver. Silver and gold. Silver and gold. So I'm going to multiply by the square root of 3x plus 3h plus 4 plus the square root of 3x plus 4 over the square root of 3x plus 3h plus 4 plus the square root of 3x plus 4. There's the conjugate. Now, a lot of you may be saying, well, Hubert, you're putting all the radicals in the denominator. Well, that's fine because h is going to go out anyway, so it'll be all right. Now, when you do this, that gives you a minus b times a plus b, which is shortcut number what? Number 3, which is a squared minus b squared, which does away with the what? What does shortcut number 2 do to the radicals? It does away with the radicals, Hubert. So that gives us 3x plus 3h plus 4 minus 3x minus 4, because you distribute that negative, all over h. And I'm just going to write an orange radical and a green radical. If y'all will let me, if I have y'all's permission to do that. Now we got to go to the next page, but let's go ahead and take the red pen. Oh my goodness. Oh my goodness. Oh my goodness. Everything left except for the 3. So we don't have to go to the page yet. Let's just write this out. 3 over the square root of the orange crap and the square root of the green stuff. And I'll write that on the next page, because we got to do the limit. So we're still working on part 2, finding the difference quotient. And these are the questions that you're going to see on the test. I'm going to take 3.1. I'm going to make sure 3.1 is not even on the test, because I thought 3.1 was the difference quotient. It was in the last book. Damn Russians. All right, so I'm going to copy this over here, and I'm going to get 3 over the square root of 3x plus 3h plus 4 times the square root of 3x plus 4. And that's a plus. And basically, limit as h approaches 0. And what happens to the h term in the middle? It goes out, and you're left with 3m is equal to 3 over the square root of 3x plus 4 plus the square root of 3x plus 4. Well, there's a 1 here and a 1 here. What's 1 plus 1? 3 over 2 square root of 3x plus 4. And that is the slope equation for any line at any point on the curve. Somebody tell me, what is all this? What is all this?
Algebra.
All this is algebra.
Algebra.
Now, the good thing about this is I'm going to show y'all what we're actually doing here in just a second. Mr. Jackson, you need to settle down. You're getting too loud. I got to pick on you. You're so quiet. I got to pick on you. Mr. Edwards, he's got a good picture of the ceiling. Let's see. How many ceiling and corner shots we got today? You should have seen the earlier class. We had at least 5 ceiling and corner shots. I'm like, if you're going to leave the room, just leave the room. You ain't got to show me the ceiling, you know. All right. So we've just completed part 2. We've just completed part 2. Well, here, what's part 3? Part 3 is to find your slope. Find the slope at given x. Well, we've got x is equal to what? X is equal to 4. So plug in what?
Chug.
Plug and chug.
Chug.
So M, the equation at x is equal to 4 equals 3 over 2 times the square root of 3 times 4 plus 4. And that M is equal to 3 over 2 times 3 over 2 times 4, 3/8. Ding, 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 ding. You just finished part 3. Now, am I going to give you a question that's got all these parts to it? Probably not. Am I going to give you a question with one of these parts? Yes. So it's better just to do all of it whenever you got a question. That's called extra
Practice.
Practice.
That's what it's called. I know some Tide Pods don't like to hear that, but that's what it's called. It's called extra work. Okay? And of course, I'm talking to a calculus class, so I'm not talking to any of y'all because y'all are already in calculus. So I'm talking just generally to students that hate work. All right, number 4. What do I do for number 4? Well, this is where we find an equation. Equation. Now that you have a point and a what?
Slope.
Now, I'm going to let y'all do this one. So I'm going to let y'all do it. Go ahead. There's Mr. Edwards. Now we got a headboard and parts. There we go. Mr. Edwards, I had 5 corners and ceilings this morning and 1 forehead. I had 1 forehead.
That's how it is sometimes.
Big old gigantic billboard forehead. No, I'm just kidding. I'm not joning on them. Y'all still use the word John. I guess y'all don't use that anymore. That's y'all use something else now, I guess. I have to ask my son what they use now. When you're joking about somebody, what's that called now?
I still sometimes I still say Jones. So.
They. All right. This is x of 1. This is y sub 1. Y minus y sub 1 is equal to m times x minus x sub 1. Y minus parentheses is equal to parentheses times x minus parentheses. No, using parentheses is not beneath me. I have running water in my house. I have most of my teeth, and I have several degrees, and I still use parentheses. So it might behoove you to use them. 4, 4, 3/8. So y minus 4 is equal to 3/8 x minus 12/8. Bring over dang old 32/8. And I get y is equal to 3/8 x. Somebody help me out here. What's that? 20? I guess that's 28, which is 5/4. Somebody help me out.
I got a 5/2.
So did I.
Well,
I got
yeah.
5/2.
Yeah. I'm sorry. 4 will go into 8 2 times, not the other way around. Okay. Now, well, what the heck could number 5 be? I want you to sketch everything. I said sketch. I didn't say plot. I want you to sketch everything you just did. Well, what does that mean? Well, first you got to sketch your actual. You got to sketch your actual function. Square root. That's a parent. It's got a horizontal shift of 4 to the left. One, 2, 3, 4. Now, if you didn't know that by all the parent graphs that we did in 109 and 110, if you had me, you better know it. You should still have that little sheet that I gave you with all the parent graphs if you had me for 109 or 110. Okay, what else do we have? Where's our point? 4 and 4. 1, 2, 3, 4. And we're just going to put a little dot right there. That's 0.4, 4. And what else? Well, what is calculus all about? The blank line. What's the blank line? The what line?
Tangent.
The tangent line. Well, if my ruler would quit moving my paper. And somebody tell me what the slope of that line is at 4. We calculated just a few seconds ago.
3/8.
3/8. We also know that the equation for this line is what? Y is equal
to 3/8
to
x
3/8
x
x plus 5/2.
plus 5/2. And we also know that the slope, the equation for the slope of this line is equal to, where is it? 3/2 square root of 3x plus 4. Now I'm going to show you a trick I learned in the war, and you also going to learn in calculus too. If I can find the tangent vector, somebody tell me what else I can find. What kind of vector can I find from the tangent vector? And it's not a trig function. Starts with an N. Mr. Hafner, that ceiling fan, it trips me out. I swear that thing, I need to get me one of those ceiling fans. The thing looks like the dadgum camera is making it look like the speed of the camera. You know how you can set the speed of the camera to the helicopter blades, and the helicopter blades doesn't look like they're moving at all?
It's a pretty cool fan.
Y'all have no idea what I'm talking about. But y'all do know the color of Tide Pods, right? Yep, everybody knows those.
Duh.
Well, I know you wouldn't, Mr. Michelle.
It's cotton candy flavored, Hubert. I couldn't pass it
Are
up.
they?
Yeah.
Okay, so nobody knows what we can find from the tangent vector. I'm sorry, the tangent line. I just said vector. I'm not supposed to say vector. All right. You can find, and let me find a color. I can't find the color that I want, so I'm going to use orange because I want it to stand out. If you can find the tangent vector at any point in space, then somebody tell me what this vector is called. I'm sorry. What line that's called?
Well, I don't know what it's called, but it's a 90-degree.
90 degrees, which means it's perpendicular, which is called the normal vector. Now we're getting into some Calc 2 stuff, because if you can find the normal vector and you can find you got all kinds of information for the particle in space. How do I find that normal vector? Do you need calculus for that? Yes or no?
Yes.
No. Because we did that in algebra. Dadgum, Miss Parker got that extra large red Solo cup. So M is equal to 3/8 here. What's M got to equal on this one? Come on, review algebra.
8/3.
Positive, not positive 8/3, but
Negative.
negative 8/3. You got a point and a what? Slope. Now I want you to give me the equation for the normal vector. Do that. And you are feeling very good about yourself.
Hubert,
So you
quick
don't have
question.
to squat the back end of your truck.
Hubert, quick question for you.
Yes.
So the tangent line would be the y equals 3/8x plus 5/2, right?
Green line, yes.
Okay.
And the orange line, which y'all are not responsible for in calculus, but I'm showing you where you're going with this in second calc. So now y minus 4 is equal to negative 8/3 times x minus 4. All right, I'm going to put 3 dots because Dr. Harden at Clemson was my calculus teacher. He would go, and that meant you know how to do this. And he'd put 3 dots. He's about this tall. They've got a plaque. If you go to Clemson and go to the bottom of Daniel Hall, I think it's O112. He's got a little plaque. They got a little plaque beside. He was department head he was my advisor too. He didn't advise me. He'd say, that's all he did. He always grunted. All right, somebody give me the answer. Well, I better help y'all out. Y minus 4 is equal to negative 8/3 x plus 32/3. But y'all check my math. And bring over 12/3, that'd be what? 44/3. Y equals negative 8/3 x. And check me on the 44/3. And that is the equation of the normal. And it's not called a vector yet because you don't know what a vector is. But anyway, that's the normal line. That's 90 degrees from the tangent line. Now you put this in a 3-dimensional space, you're going to have all kinds of stuff that you can get from these two lines right here. Think of it like this. Dang old David and Goliath, dang old slingshot, dang old centrifugal force, dang old normal vector acceleration. I meant tangent vectors acceleration. Dang old first, second derivative. I'll shut up. Anybody got a question? Now, are you responsible for all of this on a test question? No, but there's 4 or 5 good test questions on this problem. That's why I expanded it. Okay? So let's go over what you have to do first. I said get a point first. Then difference quotient. Then find the slope. And then once you found the slope, you find an equation, and then you graph it. And then if you want to put number 6 would be find the equation for the normal, which you are not responsible for, I don't think, unless there's a test or a homework question that wants you to find the normal vector. See how fun this could be? It can be fun if you make it fun. The reason I decided to put it in steps like this is because I found the 140-03-01 class yesterday. They were kind of having a hard time, so I broke it up into steps. You're welcome. So let's see what they ask. F prime of x. Well, we found f prime of x was equal to 3 over, what was it? 2 square root of 3x plus 4. 2 square root of 3x plus 4. And you feel good about yourself. And y of the line, the green line, 3/8 plus 5/2. 3/8 x plus 5/2. Dang old conjuring comes out tomorrow at HBO Plus. Dang old horror vector. There we go. And that's a good test question. Why do I like that test question for one of my tests? Short and sweet.
It's straightforward.
Pragmatic. Anti-bureaucratic. Anti-academic. Pragmatic. Let's do a nerd. This is, I'm going to erase that one since we did it for both classes. 3.2 is a different number for the other class. 3.2, 43, 14. 3.2, 43/14. And so far, that was a good test question. Now let's see if this is a good test question. No, not really. And I'll tell you why I don't like this one. I don't like this one because it tries to confuse you right here. It tries to. I guess that is right. It tries. It's confusing. Okay? And some people don't know what to do here. This is what you do. A. You just take the derivative of ax squared plus bx plus c. Okay, let's go back to the basics. I'm going to rewrite this with all coefficients. Well, we don't have coefficients, we've got letters and variables. Watch what I do here. Ax squared plus bx to the first plus cx to the 0. Now I want you to take the derivative of each one of those. Do that right now. using calculus, using the power rule, which you don't know yet. Technically, you do now, but take that and multiply it by that and subtract 1. Take that, multiply by that and subtract 1. Take that, multiply by that and subtract 1. Take about 30 seconds to do that. Mr. Jackson, I like that picture behind you. I want to get me one of those with like Georgia Bulldogs. You know, I want to get me one of those, but I just, every time I get the money, I spend it on something else, and I never do. But I like those tri pictures or whatever they're called. Anybody know the art term for 3 pictures? What is that? Anybody know? Get me a ceiling fan like Mr. Hafner, and get me a picture like Mr. Jackson, only with Georgia Bulldogs. I'll be set. People say, Hubert, you got several degrees from Clemson. Yeah, but when I was growing up, I lived right beside the Hartwell Dam out here. So I live within 6-8 miles of Hartwell. We spent a lot of time in Georgia when I was growing up. Can't beat them Georgia Bulldogs, even though they blow it every year, like the Atlanta Falcons and Atlanta Braves. They do blow it every year. Not a comment? Not a single comment? God.
Well, I mean, you can't argue something that's kind of true.
Yeah, they do blow it. Every year they blow it. And I like old Visor Man. I like him, the coach with the visor. I like him. Smart, whatever his name is. But I guess I liked when, what's his name was down there before him, Riggs or Briggs or whatever his name was, Ricks. They did Ricks wrong when they sent him away. All right, here we go. 2ax to the first plus 1 times b times x to the 0 plus 0 times c x to the negative 1. And what did I always tell you is going to happen with a constant? What happens with the constant?
0.
That one always goes out to 0. So you're left with 2ax plus bx plus b. And that's your answer to A. Now, I guarantee you some of y'all looked at that and went, I have no idea what they're asking me to do. But now you look at it and it goes, well, that's easy. Why do I have a problem with this question? Because you haven't even learned the power rule yet. Okay, you're in 3.2. You're doing this question in 3.2. You haven't even learned the power. How in the heck do you think you're going to know how to do that when you don't even know the power rule? So the reason I don't like this question is it's not placed correctly. This question should be after you learn the power rule. But anyway, let's do B. And when I do B, I'm going to take off and do everything that we were doing a while ago. So let's go with B. Let me write it down for y'all. So y'all see B. I'm just going to write f of x is equal to negative 5x squared minus 5x plus 3. And A is equal to negative 3. X is equal to negative 3.
Don't forget to switch your screen.
I'm fixing to right now.
Okay.
Hold on. Appreciate it. Appreciate the communication. Who was that?
It was me.
Thank you,
Yep.
Miss Seiler. Better than being weaned on a pickle. You're going to have a nice office one day. You're not going to be in a cloakroom with a desk because you didn't communicate. All right, so I'm going to take my handy dandy green marker. Negative 5 parentheses squared minus 5 times parenthesis plus 3. My negative symbol and my orange. Negative 5x squared minus 5x plus 3. All that over h. And what I plug in these green parentheses?
-3.
Nope.
Oh, no.
X
Oh,
plus
I did
H.
skip part 1. You got to do part 1. I skipped part 1. You got to find a point. You're right. And when you plugged in -3, does anybody get an answer? What'd you get? I'm sorry. I didn't do part 1. Let's see. -3 squared is 9. That's -45. -45 plus 15 is 30. -30. -27. Somebody check my math.
Yes, sir, that's correct.
And that is your point. Now we go to part 3, which is difference quotient. Or part 2, I'm sorry. Part 1 and part 2. All right, I'm going to leave it to y'all because all of y'all know how to do algebra, and this is nothing but algebra, so I'm going to let y'all do that. And limit as h approaches 0 at the end. Don't forget to do that at the end. All right, give you a minute. And if you can't do it, we all know what that means, don't we?
Mr. McClure,
Oh, Mr. McClure, that's my dad. Yes,
what's the name of this equation that we keep using again?
this is called the difference quotient.
Oh, okay.
Yes, the difference quotient. I'll write it down for you on this page, just in case you don't remember it. Difference quotient is nothing but the what? The slope, right? And it's equal to f of x plus h minus f of x all over what? H. You remember it now? I just do it in colors because I've found that helps students a lot. Darn, I done used a ream of paper. Kill the trees. People get me. People talking about kill the trees. They ought to go down to McCormick and Abbeville County if they want to save the trees. There's more trees down there, and Carter's got liver pills. But Al Gore said we were going to be dead by 2000, so. Oh, me. How many degrees does it take to get in a ream of paper? All right, that's shortcut number 1 right here. -5 x squared plus 2xh plus h squared minus 5x minus 5h plus 3. That negative is going to go across each one of these. So that's a negative. That's going to be a plus, and a negative. And that's going to be 5x squared, 5x, and 3 all over h. Now I'm going to distribute this negative 5 with those 3 terms. And that's going to give me negative 5x squared minus 10xh minus 5h squared minus 5x minus 5h plus 3 plus 5x squared plus 5x minus 3 all over h. Let's get the red pen out. That 5x squared cancels with this 5x squared. That 3 cancels with that 3. And that 5x cancels with that 5x. I can factor out an h with these 3 terms. Negative 10x minus 5h minus 5 over h. And the h's cancel. So, limit as h approaches 0 of negative 10x minus 5h minus 5. And what happens to the h term?
It goes out.
Goes out because of the h going to 0. So your slope of the equation for the slope of the tangent line at any point in space is negative 10x minus 5. I'm going to write that on the next page for you. But I'm going to leave this up for a few more minutes in case somebody got behind. And that's part 2. Now we got to find the slope. Mr. Paris is making everybody dizzy. Vertigo, I'm going to fall down. Ms. Parker, please settle down, please. Mr. Wooten, you know that there is actually a movie, a horror movie called Under the Staircase?
Is there? Is it like, I mean, starting with Harry Potter? Because
No, I'm not a Harry. No. I'm
right.
sorry. That's one person.
When was it made? Was it made like?
It was made in the early 2000s, I think, or late 90s.
Interesting. I'll have to watch it.
There's 2 of them, and one of them I think Kevin Costner is in one of them.
Okay.
He doesn't do a lot of horror movies. I think it was Kevin. You have to. There's 2 of them. One's called Under the Staircase, and then one's called Beneath the Staircase.
Are they good?
One of them, I think, yeah, both of them are pretty good.
Are you gonna watch the Conjuring movie that's coming out
Yeah, I'm gonna watch it tomorrow night.
tomorrow night? It's on HBO Max.
I think so. Yeah.
All right, I'll have to watch it too.
Yeah, it's gonna be good. I hope it's gonna be. I hope it doesn't suck like Wonder Woman 1984. That was the suckiest movie all year.
It was pretty bad.
That was awful. And such a talented actor and such a good movie before that. I mean, Wonder Woman, I mean, it was like somebody went out and got somebody off the street to produce it and direct it. I mean, it was like awful.
It was really bad.
F of it. Okay, here we go. We got the slope equation for the tangent line is equal to negative 10x minus 5. And we're going to go ahead and plug in negative 10 times, what's our point? Negative 3. And our slope for our line at negative 3 is, hold, no idea, hold on. 30 minus 5 is 25. So that's part 3. Part 4, we've got a point and a slope. So I want everybody to use the what? Point slope equation. Go to it. Miss Diaz done went to the ceiling. There she is. I have to pick on these people. They just go to the ceiling. That's what I'm going to start doing. I'm going to start
I have
just.
my phone on the desk.
There we go. All right, I'm going to start teaching like that. That's what I'm going to start doing. Now I'm going to put a red dot on that ceiling fan, and y'all going to sit there and watch it, and y'all all going to be hypnotized. And I'm going to make y'all quack like a duck. All right, so here we go. Y minus negative 27 equals 25 times x minus a negative 3. Somebody's going to miss this because they didn't use parentheses. Y plus 27 is equal to 25x plus 75. And then bring minus 27 over. Somebody take 75 minus 27 for me. What is it? 40?
48.
48? Thank you. I guarantee you somebody didn't get 48 because they didn't use parentheses. Because it's beneath them. All right. Now what? That's part 4. What do we do with part 5? Dang old sketch it, don't we? Yeah, Hubert. Well, I have no idea where this one's going, so I'm going to use completing the square so I can figure out where it's going. You don't have to do this. Y'all can do it on your calculator, okay? Do it on your calculator. F of x 0 is equal to negative 5x squared minus 5x plus 3. And that's going to be negative 5x squared minus 5x plus blank is equal to negative 3 plus blank. Factor out of 5. That's going to be x squared plus x plus blank is equal to negative 3 plus negative 5 times blank. Half of x, 1 is 1/2. That'd be 1/4. 1/4, and 5, negative 5, x plus 1/2, quantity squared,
Priority 1
is
message
equal
coming
to
in on secured channel.
5/4, this is 12/4. What is negative 12 and negative 5? That's negative 17/4, isn't it?
Priority 1 message coming in on secured
So
channel.
that means our vertex is 1/2, negative 1/2, comma, what is this? 4 will go into 17. 4 times negative 4 and 1/4. Positive. 4 and 1/4. Y'all check my math on that. Divide by negative 5 over 1. Negative 5 over 1 multiplied by 5. 1 over 5. And that's going to give us x plus 1/2 quantity squared is equal to, crap, negative 17 over 20. 17 over 20 be positive because of the negatives. Well, that sucks. And take the square root of both, and that's going to be x plus 1/2 is equal to square root of 17 over 2 square root of 10 and plus 1/2 or minus 1/2. Well, square root of 17 is 4.1, so, or 4.2. So I'm just thinking out loud. So that's positive or negative 4.2 over 2 times square root of 10 is 3.1. That's 6.2 minus 0.5. So 42 divided by 62. Let's see what will go into both of those. 2 will go in there. That'd be what? Let's see, 4, 6, 7. Nope. I'm trying to think of, let's see, 7 will go into both. Add that to 63. I'm thinking out loud, just ignore me. That's going to be 6. So that's going to be 0.6 over 0.9, which is 6 over 9, which is 2/3, which is 0.67. So I'm going to say that's around positive negative 0.67. And so positive 6.7 minus 0.5. That's going to be a 0.5. I'm sorry, 0.5. That was not a 5. I was thinking that was a whole number. All right, positive 6.7. That's going to be 0.17 because we're subtracting. So 0.17 is one x-intercept, and negative 1.17 is the other x-intercept, I think. I'm doing all this in my head, so y'all just have to excuse me. All right, so now I'm ready to sketch. I'm ready to sketch this thing. And the reason we're sketching it is so you can understand what the hell you're actually doing. All right, so I'm going to, this thing is up, it's right above the origin. So I'm going to draw it kind of like this. Like that. Let's see, we got a y-intercept of 3. We got a vertex of negative 1/2 and 4 1/4. We got a x-intercept of 0.17 and a y-intercept of negative 1.17. Y'all, I got something that looks like that. Now,
yeah, that's what mine looks like too.
They want us, let's plot -3, -27. Well, I have no idea where -27 is, so I'm just going to do -3, that's 1, that's 2, and that's 3, and we're going to put it right there. That is -3 and -27, and they want to know what the slope of that line is. Well, it's going to be positive slope. Let's look and see if we got a positive slope. Our slope is 25, and guess what? It's positive. M is equal to 25, and the equation for this line is y is equal to 25x plus 48. And again, the reason I'm showing you this is because in second calculus, you're going to be doing this on a 3-dimensional graph. And you got to be able to understand what you're doing here before you transfer over to that 3-dimension. Okay? I'm not going to worry about the answers because we've answered everything that we need to answer. I know I answered your question. So I'm not worried about that. Any questions from y'all? Hopefully it makes better sense when you do it like this and you actually see what you're doing. Because I guarantee you, there are people that go through the whole semester of calculus and don't know what the hell they did the whole semester. At least you know what you're doing with this. If you don't, then don't tell me because that'll hurt my feelings. All right, let's look for another one.
Hey Hubert, do you mind if
Yes.
I leave a few minutes early? I have to start
Amber,
getting-
we're running over again. I'm running over. Yeah, go ahead.
You've
You've already been here this week. I'm gonna look at one more homework question before we close up because I got 6 minutes. Let's look at 3.251/16. 3.251/16. And I don't know what this one says. Okay, this is a question about what is the slope doing? Okay, this is not mathematical. This is 100% looking at it. It's 100%, I don't know what you call it, summarizing, analyzing this graph right here. So I'm going to draw it for you. And it's 1, 2, 3. 1, 2, 3. And we've got a vertical asymptote at 2, -2. And a vertical asymptote at 1. And we've got a line going this way. I'm going to kind of exaggerate the line so I can show my point. So my lines may look a little bit curvier, but the reason I'm curving them a little bit more is to try to get my point across.
Can you switch your screen?
I am in a second. I ain't through yet. Give me a minute. Dang, come. Y'all rough on person. All right. There we go. Well, really? How did I do that? There it is. Somehow I turned it off. I had to turn it back on. Must be Russian technology. There you go.
Stop.
Say again?
She's talking to her dog, I think.
Oh, sorry, I didn't know I was unmuted.
Okay, no talking to dogs in this class, okay? -2 and +1. And that's 2 and that's 3. -3, -1. My son's dog, I beat the crap out. No, I didn't. I beat him with a pillow because he chewed up the pillow. And I went into the den this morning and there's pillow all over the place. I took that pillow and I whipped him with it. And he looked at me like, what the hell did I do? That's why I don't like dogs. They're just stupid. All right. Cats aren't stupid. Cats are smart. They know how to manipulate people. All right. So here we go. Watch this. Watch what I do here. I'm going to take my handy dandy orange marker and I'm going to pick 3 points on each of these lines. I'm going to pick a point here, a point here, and a point here. Mr. Wooten, y'all making me paranoid. I'm going to pick a point here, a point here, and a point here. I'm going to pick a point here, a point here, and a point here. And I'm going to pick a point here, a point here, and a point here. Now I tried to pick the extreme points because when you're like on this side right here, it's hard to see what I'm trying to show you. Now watch this. I'm gonna use the green for this. Trying to get you to see something here. I'm exaggerating this last spot. Can't hardly see it. I'll pull it out a little bit more. There we go. Now, what's happening with the orange slopes?
They're all positive.
There you go. All of them are positive. So what's happening is the actual derivative, let's draw a line right here. I'm going to draw a line. Somebody tell me what this line represents. It represents the vertex. Now, I don't know where the vertex is. And I don't really know if they want you to know or not, okay? What I'm trying to show you is that up until this point right here, wherever the vertex is, we don't know where it is, but wherever it is, these right here are all positive. So your function is positive, it's increasing to that as far as the slopes. Does everybody understand that? The slopes are all positive. Does everybody understand that? They're all increasing. And then what happens over here with the green slopes?
They're all
The
negative.
green slopes are doing what?
Decreasing.
They're going down. They're decreasing. So here the slopes are increasing. Here the slopes are decreasing. They can't touch either because this is a vertical asymptote. And these two lines cannot touch. So you're looking for a graph that is increasing and decreasing but not touching. Is this a test question? Probably not. Because, I mean, it's a good homework question. I don't mind it being a homework question, but I just don't want to use it for a test question. It's not this one because this one touches. This one is just the exact opposite of that, and that's not going to happen. And this one, that's not it. So it's this one because this one's decreasing and this one's increasing. Okay? And you could say that this one, yeah, no, this one's not increasing. I think this one is correct. So we're going to end on that one. All right. So anybody, okay, what y'all should be working on as far as homework, y'all should be working on 3.1. I don't really care too much about that. I really want you to work on 3.2. I don't know what 3.3 is. I think 3.3 is actually the going into, yeah, that's the power rule and constant rule. We've already covered that. Sorry. And 3.4 is the product and quotient rule. Okay, so yes, yes, and 3.5, I think we're going to go into the chain rule, and we haven't done that yet. So don't even worry about that because we haven't even done that yet. We still got to finish product, and this is technically, this is where you should be as far as where you are with the homework. You should be working on these three and maybe, you know, tinker with this a little bit, but I'm really not finished with this. So this right here should take precedent over this right now because I haven't finished this yet. And for 3.1, that's why I went ahead and showed you a couple of those problems. 3.1 is okay, but when I teach calculus, I don't use the instantaneous velocity because I find that confuses students when you're working with the difference quotient. So that's why I don't teach it together. All right, any questions? Let me look at the roll and see if anybody's missing. Let me turn this off and turn this off. And it just take me a minute to pull it up. I don't have it pulled up, so they shouldn't log me out. And they did.
I have a question for like all the other students in the class.
I'm off the clock. So,
Does
go ahead.
Does Microsoft Teams make any of y'all